I briefly mentioned voltage in the first lesson, and that the voltage that we get from the wall outlet is either 230 volts or 120 volts. If you are not sure what voltage and current is, I encourage you to go have a look at our dedicated series on that, but here's a basic explanation. Voltage can be thought of as a pressure generated by a water pump in a pipe system. This pressure will cause the water to flow through the pipes. We also know that the higher you turn up the pump, the more pressure will be generated and more water will flow through the pipes. Voltage and electrical current is very similar to this water pump analogy. The higher the voltage, the more electrical current will be pushed through your circuit, and if we lower the voltage, less current will flow. This is why you will often read in books that voltage is directly proportional to current. The higher the voltage, the higher the current, and vice versa. Another way of saying this is that the flow of current is the resulting voltage. So to get back to the voltage from our wall plugs, this voltage is way too high for most household electronics, since most devices use voltages in the range of 5, 9, and 12 volts. So we'll need to find a way to lower the voltage so that we don't damage our devices. This device here is called a transformer, and this amazing device will do just that for us. This model transformer is going to take the 230 volts and reduce it to 12 volts. Let's use a pocket scope to illustrate this, so please follow along with me. I'm now going to create a new pocket scope and set the following properties. 400 pixels wide, 5 seconds for the time, leave the grid lines at their defaults and set the minimum to -240 and the max range to 240. Then click Create. Now let's create two graph lines. I'll call the first one Wall Outlet. This line is going to show us the wall outlet voltage, and I will make this line white. Click Create, and then call the next one Trans Output, and we will make this line green. We'll use this line to show the voltage after it has been lowered by the transformer. I'm also going to click Run on the scope so that we can see the results once we made the connections. Awesome! Now we can go to the Connections window and make our connections. Let's first connect the wall outlet output here to the wall outlet graph. This is the input graph line that we created earlier. Immediately you can see this oscillating line here on the scope. This is the wall outlet that we're looking at. Okay. Now let's connect this wall outlet to the transformer input. The output of the transformer is not connected to anything. So to see how the transformer performs its magic, we need to connect it to the transformer graph line input. All you need to observe at this stage is that the transformer is taking the wall outlet voltage, which is the white line, and reducing that voltage to this lower voltage, which is the green line. That was a bit of a mouthful. So to end this lesson, let me draw this for you. The white line is coming from the wall outlet here, and this green line or voltage is coming out on this side. In the next lesson, we'll talk about these lines, and why they go up and down like that. We'll also see why most of the time this is not a good thing, and another problem we'll need to solve.